So in your class, you'll see this lemma, and that is, we have two integers a and b with GCD g, then there exist integers m and n such that a times m plus b times n equals g. Okay. So it turns out that in computing the GCD of a and b through the Euclidean algorithm, we already have done half the work that goes into finding m and n. And so to illustrate this, let's look at the example of when a is equal to 39 and b is equal to 24. So our first step, use the Euclidean algorithm to find the greatest common divisor of 39 and 24. So we start by writing 39 equals 1 times 24 plus 15. 15 is not zero, so we continue. 24 equals 1 times 15 plus 9. 15 equals 1 times 9 plus 6. And 9 equals 1 times 6 plus 3. Now, lastly, we have 6 equals 2 times 3 plus 0, and we stop. We know that the greatest common divisor of 39 and 24 is 3. So now we can update our sort of goal here. So we want to find m and n such that m times 39 plus n times 24 equals 30. Okay. So the first step is to take all of the equations where the remainders are non-zero, and we're going to rewrite them so that we just have the remainder on the left. Right? So what I mean by this is we're going to turn this into 3 equals 9 minus 1 times 6. 6 equals 15 minus 1 times 9. 9 equals 24 minus 1 times 15. And lastly, 15 equals 39 minus 1 times 24. Okay. We're going to start with our equation for 3, which is the GCD of 39 and 24. So start with equation with GCD of a and b. Okay, so we have 3 equals 9 minus 1 times 6. Well, it just so happens that we have an equation for 6 here, right? 6 is equal to 15 minus 1 times 9. So we're going to update this equation using that knowledge. This becomes 3 equals 9 minus 1 times 15 minus 1 times 9. So this is also equal to, strip to negative 1, 2 times 9 minus 1 times 15. Okay? But we also have this equation for 9 here. So we're going to update our equation again. So we have 3 equals 2 times 24 minus 1 times 15 minus 1 times 15. Okay? Simplify everything. 2 times 24 minus 3 times 15. Okay. So our last equation is one with 15. So after we make this substitution, we'll be done. 3 is equal to 2 times 24 minus 3 times 39 minus 1 times 24. Okay, simplify everything again. So 3, distribute this, we get 5 times 24 minus 3 times 39. We have no more equations to plug in. We have something involving just 24 and 39, right? Which was our original goal, as well as the GCD. So, in this case, we'll have that 5 is equal to n, and negative 3 is equal to m. And to check, you can just multiply 5 and 24. This is 120. Negative 3 times 39 is negative 117. 120 plus negative 117 is 3. So all of our work is correct. Okay? So we finished part 2 of our problem, right? We found that m equals negative 3 and n equals 5. And we're done. So this entire process is called the extended Euclidean algorithm. You first do the Euclidean algorithm, you use its results to sort of re-expand your equation to get these coefficients.